It's our pleasure today to talk to Michael Wooldridge. Professor Michael Wooldridge is the head of Department of Computer Science at the University of Oxford, and he's also a fellow of Hertford College. And in addition to that, he's been working on artificial intelligence, or AI, for over 30 years. He's also been the president of the European Association for AI and the president of the International Joint Conference of AI. And more recently, he is the author of a new book called The Road to Conscious Machines, published by Pelican. Professor Wooldridge, welcome to the podcast.
Be a pleasure.
Before we look at the book, tell us something about yourself. How did Michael Wooldridge get involved in AI, and what was the interest in that? How did you become Professor of Computer Science at Oxford?
Well, I studied computing as an undergraduate in the 1980s, and I was that sort of first generation who came across a computer as a teenager. So I think at the age of 15 or 16, my parents bought me one of the very, very first generation of home computers, the Sinclair ZX80, which was a very crude and even by them, the standards of 1980 was a very crude and primitive machine. But I really enjoyed programming, and I enjoyed the idea that you could just create completely new things on computers, and that it was thought stuff. I mean, computing is kind of just bounded by your imagination. I mean, if you're an architect working in the real world, then you're limited by the limits of concrete and steel and glass. But in computing, it's your imagination is the limit, and I always really enjoyed that. So I studied computing as an undergraduate, and the one bit of computing that I really fell for was AI. And I guess the reason was because there seemed to be so many sort of, well, firstly, very deep questions in AI. I mean, really fundamental questions, which appeal to our status as Homo sapiens. You know, if we ever succeeded at the grand dream of AI, then that would presumably have something to say to what it means to be human, and that's quite profound in itself. So I was fascinated by that. But actually, more than that, I think it was just that there were just so many unsolved problems. There are just completely open vistas in AI, so many unsolved problems that you can work on. And when I started to do research, that's very appealing. The last thing you want to do when you do research, I'm sure you know, is work in an area which is just overmined, where there's 1,000 other people working on the same problem. And here there's just completely uncharted territory everywhere. So I think that was it. I mean, I found it a fascinating subject and just so many unsolved problems. And how did I get to Oxford? Very slowly. Before Oxford, I was at the University of Liverpool for a long time. I'd worked briefly in Oxford, not in the university, in the 1980s, and always really enjoyed being in the city. An opportunity came up, and that was it. I got very lucky.
Oh, well done. I think Clive Sinclair is responsible for quite a few people joining the computer science field.
I believe so,
I didn't
yes.
start with the ZX81. I think I saw the Spectrum computer in Woolworths in Chester, of all places, at one time, and was so fascinated by it. In fact, I was quite annoyed because I saw a number of very young kids working on this thing and doing remarkable things with it, and I thought, I'll have a go at that, and I couldn't do anything with it at all. And I could buy one and make sure I understood it. Tell me about the book, though. Let's move on to that. Why did this particular book need to be written? The Road to
well, so artificial intelligence 20 years ago, you know, it was the only place you saw AI was in the movies, and it wasn't a very hot research area. I mean, there weren't terribly many people interested in working in AI. It wasn't something that bright young students would think of making a career in. And that started to change. I mean, it started to become a hot topic around about 10 years ago, and really started to take off around about 2013-14. And what happened was I was sat at my desk in Oxford and the phone rang, which is a bit unusual these days in its own right. I hardly ever use the phone these days, but And it was, I think it was the BBC or maybe Channel 4. But anyway, the point was they said, there's this guy, Elon Musk, and he says AI is this thing which might destroy humanity. And we wondered if you'd come on our program and talk to us about that. And I have to say, I said no. I mean, that doesn't happen in those days anyway. It didn't happen all the time, but I bottled it. I didn't quite have the nerve to go on the program because I guess I thought they would get somebody smarter or better informed than me. And they didn't. And that's the simple truth. And this kind of went on. A few weeks later, it was Stephen Hawking, made similar claims that he was worried that AI was an existential risk for humanity. And I was looking around to see who was standing up and responding to these, and nobody was. And I guess I felt, and the media, as I'm sure you saw, became full of stories about AI. And actually, the slightly comical thing is they are either, AI is this incredible thing which is going to solve all our problems, or AI is going to destroy us all. It's deadly, and we must ban it now. And it was there was no narrative in the middle. And I didn't recognize the field that I worked in. And so after a while, it just dawned on me that nobody was going to stand up and tell the story. And that really, that as a scientist who takes public funding and who works in this area, I kind of have an obligation to try and inform people about, as best I can, about what I see the reality of AI is. So that's what the book's about.
So it's to counter people like those who see a real danger in. I mean, let me
not just the danger. I say there's also this kind of rather Silicon Valley overexcitedness about AI, which within our grasp, that these machines that are robot butlers, all the rest of it are within our grasp. But and there's those two narratives out there, and neither of them, I believe, is really grounded in reality. So it's countering both of those.
Yeah, you mentioned Elon Musk, and you mentioned Stephen Hawking, and let me give you a quote from Elon Musk. He says, talking about AI, artificial intelligence, "It is the single biggest existential crisis that we face, and it scares the hell out of me." And Stephen Hawking, he added roughly about the same time as you say, AI could spell the end of the human race. It could take off on its own and expand at an exponential rate. So you're saying they're not right, but why not? What's the argument against though? Why are they?
It's two very brilliant people who've achieved far more in their lives than I have and ever will, I'm quite sure. But I think what it comes down to is a misconception about progress in AI. We have seen progress in AI. We've seen really quite dramatic progress in AI in the last few years. But the important thing is to understand what that progress means. The problem is, and I've learned this through bitter experience, when I say, oh, there have been breakthroughs in AI, what people hear is robot butlers tomorrow, that, we're on the edge of some super intelligence explosion, that kind of the grand dream of AI is within our grasp and so on. And actually, that's not what I'm talking about at all. I'm talking about, a breakthrough in AI is a nice mathematical result which resolves some, problem that we've been stuck on for a while. But if you look at where we've seen these, what I call breakthroughs, here's the really important point. They're breakthroughs in getting computers to do very, very specific, very, very narrow, to use the commonly used terminology, very, very narrow tasks. So a machine which gets superhuman performance in playing a game of chess, or the famous one in the last few years, playing the game of Go or the game of StarCraft. I've never actually played StarCraft, I'm too old, but it has this superhuman performance on a tiny, narrow thing. It is a program which is optimized and optimized and optimized to do that one thing extraordinarily well. And in the end, it can do that thing better than any human being can, but it can't essentially do anything else. It's just a program which does that. What about
those programs which Google are working with at the moment? I forget the name of it, the deep something or other deep.
Yeah.
You just give it the rules of any game, and it's worked its way through all the Atari games. It's worked its way through Go. It can now beat every human being on the planet. And simultaneously.
But these are actually really the game of Go or chess or checkers or the other games that they're working on they appear to us to be rather complex tasks. I mean, I play chess. I don't play it very well. I don't know you. If you play, you could almost certainly play better than me. So we associate this idea of being able to do well in chess with intellect, right? It feels like if you're good at chess, you know, this person must be truly intelligent. They're truly, I mean, the chess playing programs that do well in this very, very, very narrow realm. And there is generality. DeepMind, the company that does that work, I mean, they are one of the companies that produced a lot of these breakthroughs. But being able to do well in board games doesn't mean that we're on the cusp of some general super intelligence explosion. It really doesn't. They don't exist in the real world.
Okay, what would you say to this argument then, that solving a problem like a game is just really a pattern solving problem of a complicated nature? Maybe something like chess and Go in particular is a pattern solving problem, but maybe all life is just a pattern solving problem, and that if you can do it with games, then maybe you can also just extend that out into real life and solve all the problems that life presents us with. And therefore, it becomes much wider field than just game playing.
Sure. So I think that's the nub of the argument that's currently being used. And I don't object to the idea of a suitable level of abstraction. That's all we do. We respond to the situations that we find ourselves in. And if you can train a program sufficiently long in similar circumstances, then maybe it could, in principle, and that's really important phrase, in principle, achieve the same kind of capabilities that a human being has. But let's just look at how those programs that are very successful at what they do and represent breakthroughs in their own right, how they do that. Okay, so you mentioned the Atari playing program. So DeepMind wrote a single program to play 49 different Atari video games. And with roughly, I think, 30 of them, it learned to play at or better than human level ability. Some it didn't do, it had no skill at all. Okay, how does it do that? It uses a technique called reinforcement learning. What reinforcement learning does is a very, very simple idea. It starts out, it doesn't know anything about, nobody tells the program anything about the game it's playing. It just starts out by playing at random, doesn't know what it's doing. All it sees is the screen and the score. So it's playing, let's say, a game of Space Invaders, and it's just playing randomly, and it manages to hit the fire button and it destroys one of the Space Invaders. And immediately it gets a score, right? And then gets some points for destroying one of the Space Invaders. So what happens in reinforcement learning is that when you've achieved that, when you've got that score, the program says, okay, I've got some score, I've got a reward, to use the technical term, right? What that means is I'm now going to, in the same circumstances, I'm going to be more likely to do the same thing. So if I encounter a situation that looks roughly the same, I'm much more likely to take the same action, press the fire button. And then it just repeats that iteratively over and over and over again, and it gradually learns. Now that hides an enormous amount of mathematics and complex, very sophisticated programming, actually, but even more mathematics. I mean, there's really an awful lot of that is what it boils down to. And that's called reinforcement learning. And in that way, those programs using what's called deep learning learned to play those Atari video games. And it's an impressive result in its own right. But here's the thing, while it did that, the player in that Atari video game got destroyed thousands upon thousands upon thousands of times, right? Now, it doesn't matter. It's playing a video game. It doesn't matter if you get destroyed. You just go on and you play the next game. And that's exactly what it did. But you can't do that in the real world. That's not how you can learn in the real world. And that's certainly not how we learn in the real world, right? So the techniques that are so successful in those board games, and it's the same idea that's used, you just play games of chess, play games of Go, and lots of other techniques are used there as well. So I'm oversimplifying somewhat, but you just play repeatedly. And using that basic idea, if I discover that I did something good, it's going to make me more likely to do that again, right? And hiding lots of sophisticated programming and mathematics behind the scenes, you can learn to play these games very, very well. Put a program like that in the real world. Could you get a driverless car to learn how to drive like that? No, of course you couldn't. You couldn't even think about doing it. Could you get a robot to learn to clean up an office like that? Of course you couldn't, just by randomly taking actions and seeing what happens. Of course it's not going to work. So there are really big limitations to what those techniques can do. And at the moment, what those techniques don't do, and what I don't see any prospect of them doing, is working in the real world.
Okay, going back to Mr. Elon Musk, of course, he's famous not just for his pronouncements on AI, he's famous for producing the Tesla car, much of which is a self-driving car. So supposing we take some of these training programs or reinforcement programs which have learned how to do various things, put them into things like machines, like cars, doesn't that make them, I suppose, more able to cope with real world situations then?
Yeah, of course, it's controversial at the moment. I mean, there are controversies around Tesla's Autopilot program. In its own right, it is an impressive program. I mean, this is so the program and the option that you have on Tesla cars, that essentially the car can assist with driving. And I mean, one of the, I'm not privy to the details of how they developed that program, but I do know how those programs are developed in other driverless car companies. And the way it works is they go out on the road for thousands of hours with human drivers, getting data, and then looking at what the human does for in this particular data situation, and the program learns from what the human does. And the data is very carefully annotated with, that's a stop sign, that's a pedestrian, that's a bicycle, so that the program can learn to recognize stop signs and pedestrians and bicycles. But roughly, you know, the human behavior is used to drive the how that program will behave in the future. But there are big limitations to what they can do. I mean, I think there are some difficulties with calling the program Autopilot. I think that's very misleading for people, potentially. I mean, there is some anecdotal evidence, I believe, that people put far too much reliance on the program. That is, they assume it's operating at a much higher level than it actually is operating. Tesla, to be clear, are very clear that, you know, you should not take your hands off the wheel at any time and so on. But people treat that as if it's what's called level 5 autonomy, which is the car is completely in control. Whereas in reality, it's much lower down. It's a level 2 autonomy. I think that's, incidentally, that's one of the challenges for driverless car technology in general, right? I mean, if it really was level 5, you would know what to do. Nothing, you know, there isn't even a steering wheel, so you can't do anything. And then down at level 1, you have to do everything. But for everywhere in between, it's much less obvious, I think, what the driver needs to do. And for the adoption of this kind of driver assist technology and driverless car technology, I think that's a bit of a challenge. Yeah. But what Tesla doesn't do is doing the reinforcement. It's a different technique to the technique that you know, that DeepMind are using in their Atari programs and their chess playing programs and so on.
Okay, I mean, I know you touch on driverless cars and you go through those within your book as well, so it's quite interesting to read that part. Let's move on to the next level of machines, though. And I've seen on YouTube, it's probably many hundreds of thousands of people have seen robots now, which can do the most astonishing things. There's dog robots which can cross terrain, and you can see almost human-looking robots which can do acrobatics of different kinds. And I suppose the worry is that you start putting artificial intelligence in these, and then you can start using them in ways which maybe we might start to be worried about. And I'm sure many people are fearful of the idea of artificial intelligence and robots walking around the streets.
Yes, so I know the videos to which you refer. I mean, the famous ones are from a company called, I think it's Boston Dynamics.
Yeah,
and they have a huge number of very, very impressive looking videos. I mean, I think you need to treat those with a hefty pinch of salt. I mean, what you don't see is how many takes it took to get before, you know, how many failed attempts the robot had to be able to do that. And typically also there's not too much actual AI in there at the moment. I mean, these are more or less hardwired to do these clever looking tricks. And that's not to underplay the very, very clever engineering, the programming that goes into it. But I say, you didn't get to see the outtakes. You don't get to see all the failed attempts to do that. And my strong suspicion, with the greatest respect to Boston Dynamics, is that there are quite a lot of outtakes that we're not showing.
But is that really a problem when you might say, well, give me 5 more years and we'll sort that all out, and it'll be, you won't need those outtakes. It'll all be perfect. It's just a matter of time then.
I think it's unlikely to be 5 years.
Yeah.
I mean, I think the general issue, though, I think you're right. I mean, there are lots of concerns and proper concerns about a world in which we coexist with robots. And yeah, I talk about some of those in the book. I mean, I think the biggest concerns that people have are, well, I mean, there will be discomfort if we start seeing robot street cleaners and so on doing that kind of thing. I mean, that will be an adjustment. I don't think that will be something. I don't think that will be a fundamental. I don't think that will be a fundamental barrier in society. I don't think it will be stopped. I think the biggest issue that's drawn attention there is kind of lethal autonomous weapons. It's what happens if those robots are equipped.
Go on to the next level there. I think that's the. I mean, does that keep you awake at night, or is that something you're not concerned about?
No, it does, and I am concerned about it. And so there's a scenario that I think people tend to imagine that scenario as being like the Terminator one, that you'll have robots walking down the street doing this sort of, remorseless, relentless killing. And I think that's not the kind of scenario that I think is the one that you need to focus on in the near term. I mean, I think there are much more immediate scenarios, but very real ones. And so the particular scenario that's presented in the book, which is not mine, it's due to Stuart Russell, a very renowned AI researcher in Berkeley, is this. So imagine that we take a remote control helicopter of the kind that you can buy for £30 in your local supermarket, one of these little remote control quadcopters. And nowadays they're equipped with cameras, and actually some of them can, they're very useful for surveying buildings and things like that. So there's been big take up of them. They're very cheap now and very good. So imagine one of those, which is equipped with a camera and a small computer, and you don't need anything very fancy to do this. A camera, a small computer, and basically a hand grenade sized lump of explosive. And the AI on board on the computer basically just navigates streets, just has a built-in map of the streets, and using the camera with some added intelligence, it just searches the streets systematically, looking for a human form. It doesn't need to recognize that human form. It doesn't need to recognize Philip Davis or Mike Wooldridge. It just needs to recognize a human form. Right, that's a human being, and when it sees it, it just flies down and explodes. Now, those things could be could be cheap as chips. They could be, they would cost pennies to build. Right, they wouldn't be much more expensive than a regular hand grenade. And imagine those being deployed on scale, thousands of those on, deployed by a dictator who wanted to suppress a population somewhere. That's a terrifying prospect. I mean, a really genuinely terrifying prospect.
Our capabilities now?
And I think, yes, my impression is I think the capability to do that now is absolutely there. It would just require the will to do it. I say that scenario is one that's been discussed in the community quite a lot. I mean, more generally than that, though, I mean, is the idea of with drone vehicles that are used by the military quite routinely these days. The idea that they might be equipped with more sophisticated AI, which would recognize, essentially, as you mentioned, doing pattern recognition on targets. Basically, you recognize something that looks like a tank, and so you go down and take it out. And there, the point is that the line in the sand is that the machine itself is equipped with the decision to press the fire button. And then by corollary, the decision to take a human life. And that, I think, is, for an awful lot of people, is just, so abhorrent that there's no discussion to have about it. That's just something that we do, as a global society, it's somewhere that we don't want to go.
Yeah, it's interesting because it seems a very small step to have these remote control drones which fly into different places and then kill people when they're there, and to just switch that to being autonomous and let them go and make that decision itself. And yet there's a great deal of reluctance on the one, but it seems quite acceptance on the human motivated or moved drone. Doesn't seem to be that worrisome, but the robot one is, isn't it? Is that because it feels it's outside of our control completely?
Yes, I think so. I think that's. I think I mean, I think the sanctity of human life is something which is very, very precious. And the idea that we might be prepared to give the decision about whether to take a human life to a machine is cheapening it. I mean, that's my reading of it. I mean, you would need to talk to a philosopher, I think, to get deeper into that. But that's the kind of the sense of that. I think there are some very practical concerns about, about killer robots. One of which is if you're no longer putting your troops on the front line and you're not risking, the lives of your citizens by doing that, which traditionally, of course, you do, and in conventional warfare, that's a factor. How many casualties would we be prepared to accept in order to win this conflict? And that you will take that into account when you decide whether the conflict is worth engaging in. But if there are no casualties at risk, then the cost of the conflict for you becomes much lower, and the worry then is that makes warfare a much easier decision to engage in. So there are a bunch of different concerns about that.
You have a kind of drone war approach to things where you just send your drones out and they send their drones out. Maybe.
Yeah, which is, and there is a view. It's not a majority view, but I have heard the view expressed that surely that would be better than doing it with people. So there are some complexities to the argument. I have to say, my sense is the overwhelming majority of the AI community is very strongly opposed, not universally, but the vast majority is strongly opposed to lethal autonomous weapons.
As far as I understand it, we're not actually at that point yet, but we are at the point where machines are making decisions over human lives, aren't we? In a more general kind of mundane way, where people's mortgages maybe, or other decisions, whether they can have a license for guns or other things like that in America. I think AI is being used much more in those kind of fields, aren't they? And that does put machines in a position of, I suppose, authority or control over human beings. Is that a problem too, or not?
Yes, and I think there's lots of difficulties here, which I talk about in depth in the book.
Yeah.
I mean, one of the difficulties is that there's an awful lot of naivety about AI technology and what it can and what it can't do. And you get a company, and let's say this is a fictitious example, but it probably isn't fictitious. Actually, somebody's probably trying to do this. You want to decide whether to give somebody a bank loan, and so you look at a bunch of, you'll look at a form that an applicant fills in, which has got their salary and their current commitments and so on. And at the end, you give a yes/no decision to that. So it would be a classic AI application, machine learning application. You show it lots and lots of bank loans. And you tell it which ones have been successful and which ones have been unsuccessful, where people have defaulted on the loan. And then in the end, the program has to decide for itself whether to give a loan or not. But the problem is this technology is really, really brittle, and it fails in all sorts of weird and unpredictable ways, and for all sorts of reasons that we would find just bizarre. Reasons that even the most naive human being wouldn't fall prey to. And so there is naivety about the technology. You try it on 100 examples and it gives you the right answer, but then you try it on 101st and it just gives you a completely out there wrong answer. And there are many, many examples of AI technology doing that. And the truth is, we do not understand at the moment exactly the boundaries of where the technology works and doesn't work. It's one of the big unknowns.
Is that not really merely a matter of the data set wasn't large enough? The training data set wasn't, if you multiply the training data set by 100 or 1,000 or even 1,000,000 and give it far more cases to look at, then surely it would eventually trap everything and get the right answers for the whole lot.
Good question. More data is always good, but the more data you have, the more effort you have to put into it to do the training process. There are certainly issues with data sets that are too small. That's a classic problem in machine learning. If you go to the bank loan example, if you train your program on just two instances, one of a white male that earns £100,000 and one of a white female that earns £80,000, if those are the only two training instances you get it, then there's a real chance that it will only give loans to people that match one of those two characteristics. which is called overfitting. So finding the right data sets is really a big issue, but actually at the moment we don't know, we don't really have a robust understanding of how much data is going to be needed to get reliable answers. More than that, actually, what typically happens is you choose a subset of the features that of the form to train these things on, because in general, as you know, the more data, the more information you try to train it on in terms of the longer the details, the more details that you provide about a person when you're trying to train it for one of these loans, the harder and harder and harder it gets to do the training process. So typically what happens is you identify just some of the things that you want to train it on. You know, for example, what might not you want to train it on? It's kind of irrelevant whether somebody has a dog, for example. I don't know why that would be on the form, but you get the idea. You just wouldn't include that. And if you did include it, then you'd have to do an awful lot more work on the training process for it to learn about those things. But again, there are endless cases where if you don't include the right data, then it just learns to make bad decisions. Even if they superficially look like they're good decisions. And this is where the issue of bias comes in decision making. So it's, I take your point completely, but actually knowing how much data you need to train is a really problematic issue. But more than that, you still end up with cases where the program can just fail in very, very weird ways at the boundaries.
Okay. So, I mean, that's obviously one of the difficulties and dangers of using AI, and you may have biased outcomes from that. But are there any? I mean, we've looked at some of the more headline-grabbing dangers that people like Elon Musk have suggested are for AI. But as you yourself look at it, what would you say are the dangers or the problems of AI? I mean, are there more mundane but more immediate and real problems that we face, possibly?
Yeah, I think one of the ones is what I call algorithmic alienation in the book.
Yeah.
And this is a manifestation of a very old trend, which goes right back to, I call it alienation because it goes right back to Karl Marx, believe it or not, and his theory of alienation. And Karl Marx was writing at a time when the factory system was just being established, and it, you know, the first industrial revolution in the UK. And what he noticed is that people were working on jobs that were just kind of meaningless to them. You know, if you're in a factory, you're doing a very repetitive task, potentially part of, you know, not in Marx's day possibly, but nowadays as part of a much larger production process. Maybe you don't even see the finished product. You probably can't afford the finished product. The thing that you're doing is literally meaningless to you. And you have, at the same time, very little control over what you're doing. There's very little scope for you to exercise your individuality or your initiative or anything like that. And as a consequence, Marx said, people are alienated from their work. It doesn't mean anything to them. And so the AI spin on that is that AI technology coupled with things like smartphone technology in some jobs makes it possible to monitor and instruct people down to the minutest detail of their job. So factory work, warehouse workers is a famous example. You know, people who are assembling packages in factories, and they're told to go. You know, this is an example that a colleague gave me. You know, you're told to go to aisle 13, shelf B, and to pick 5 items off shelf B, and then another 5. So you've got 10 items. Well, why didn't it trust you to take 10? Because it doesn't trust you to take 10. It doesn't trust you to count to 10. Right? So it tells you to take 5 and then take another 5. And it's instructing you literally moment by moment, turn left here, turn right here, you know, that kind of micromanagement of somebody's working environment. Now, okay, you might say, well, yeah, okay, but that's you know, warehouse jobs are not tremendously rewarding jobs anyway, but there's real scope to do this in white collar jobs. You know, imagine if all the emails that you send are scrutinized by AI with sentiment analysis, and every email that you send, you get a critique of it back. wasn't a very polite email you sent, Michael. That's an important customer, and I think you could have been more respectful in the email that you sent. And then at the end of the day, it says, you're 20% less productive today. Yesterday, you dealt with 33 customer inquiries. Today, you've only dealt with 21. We'd like to see a bit more improvement tomorrow, and going beyond that, potentially, an AI program being part of your annual assessment, your assessment, or maybe even, deciding whether you stay on in this job. And the kinds of programs that I'm talking about, by the way, are on the market now, right? Now, not in the full detail, not deciding whether somebody should stay on in the job, but looking at people's email and judging the tone of the email and giving feedback on them. That kind of thing exists already. So that I find, and the thing about that is it reduces jobs where at the moment people have a good degree of judgment and control over what they're doing, and the ability to organize their working day reduces them down to the same level as production line jobs where you have no control over what you're doing. So that, I think, that's a new aspect to an old problem. I say Karl Marx, I think, would have immediately understood what the issue was. But I find that quite a depressing and scary one, and I hope we can avoid going there.
I mean, what you're talking about here is a reversal of roles, really, because we've always thought of as machines being the servant of human beings. But here you've got a situation where essentially the machine, the computer, the AI machine, is making decisions and informing the human what to do and how to do it. And that robs the human being of something like purpose and
agency,
and even agency, and ultimately a goal to do something for themselves and to make something productive for themselves. Instead, they're being controlled by machinery, which is a soul-destroying event, I think, in anyone's life, if they're just the subject of the algorithms to tell them what to do. Is that the main issue that you see with AI in the future?
Well, it's one of a raft of issues. I mean, the other one, which I've already hinted at, is the issue of bias. And the most obvious manifestation of bias is that if the data sets that you're training your machine learning program and your AI program on, if the examples of bank loans that you're training on were constructed by people with biases, either conscious or not, then your data set is going to reflect that, and you're going to end up with biased programs. But there's other ways that bias can be introduced. It can be introduced just by clumsy programming. And you can end up with very well-intentioned work, which nevertheless is hopelessly biased. So a famous example of this is there are standard data sets for speech recognition that you can download from the internet, and they're freely available. So if you want to build a speech recognition program, and the way you train your program is you give it lots of little snippets of somebody speaking, which is neatly labeled in the data set with what they say, and your program can learn to interpret what people say. But the famous examples of these are, the people that are speaking tend to be college-educated white males. And so your program, your machine learning program, learns to recognize the voices of college-educated white males, typically American college-educated white males. You've immediately got a program which doesn't necessarily recognize female voices or accented voices in any form whatsoever. So there are bias, I think, is a really, really big issue, and it's a problem for society generally, but it's one that AI has the potential to magnify. Because I say there are untold ways in which we can be biased, and without a good understanding of what those issues are, we can end up with very biased computer programs. The good news is, I think, that the community is alive to that issue, and there's a lot of work now on overcoming bias. But to be blunt, there's a long way to go.
Tell me, do you think that bias only or can only originate with human beings, or is it possible that purely autonomous AI could originate its own bias in some respect, or is that just not possible because of its neutrality?
No, that's a good question. Well, firstly, it isn't just the data. I emphasize that. I mean, you can just write bad AI programs, which just end up being biased because you didn't construct the program very well. That's another, that's another classic source of these things. I mean, an example there was if you designed your program so that the factors that it took into account were things like race and so on, then you're going to end up with programs that take that into account when they decide whether or not to offer a bank loan, which is very, 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 very dangerous. But yes, I think absolutely, if you it's a good point that you raise. I think the more autonomy we give to machines, then the more scope that there is for them to do things that we are unhappy with. And so learning how to mitigate those risks, which we are at the very beginning of, I think is a big challenge for the community.
I mean, what would we do in a situation where you set up some kind of a neural network which is training itself to make decisions on something, and after a while you notice that those decisions are full of bias, and yet there's no real understanding of why that might be the case?
Absolutely no, and I think that's exactly one of the big issues at the moment, because these things are the neural nets that you refer to, which is one of the most important machine learning technique of the present day. These are black boxes. They can't tell us why they made a decision. They just output a decision, and they are not. You can't scrutinize them and come up with a meaningful explanation of why they made a particular decision. And in the absence of such an explanation, it can be quite difficult to accept a judgment that's being put forward by such a neural network. So no, you're absolutely right, I think, and again, the community is alive to those issues, but I don't see anybody has any solutions to them yet. So what this should be is just a caution about the technology. People need to understand its limits, and that's one of its limits.
Can I move on to the area which I think the title of your book really brings out, which is the area of consciousness. We've spoken about artificial intelligence, but consciousness is a different kind of thing, isn't it? I mean, how is intelligence and consciousness connected? Is consciousness just a matter of more processing power, or is it qualitatively different in some respect?
Well, I think we can have machines that can do things which we regard as very intelligent tasks, which clearly don't exhibit any meaningful signs of consciousness. So an example would be the chess playing or Go playing programs. We have a program that can be any living human being in the game of chess or Go, or a program which can solve mathematical theorems that would defy all but vanishingly small fraction of humanity. And so they're clearly exhibiting intelligence in some form, but not, they weren't designed to be conscious, and they're not exhibiting consciousness as well. The truth is, the sad thing about consciousness is just one of the big mysteries. And when I was researching this aspect of the book, it's not my main focus of my research, so I had to go away and do some reading. And I really was curious about whether there were any big theories which might explain consciousness. And then actually, the truth is there aren't. It is one of the big mysteries of science and philosophy. We all have self-awareness, conscious experience, and actually one of the few things that we really do agree on is that consciousness involves subjective experience, being able to experience things from one's own personal perspective. Beyond that, there's actually not much that we really do understand about consciousness, and we are a long way from being able to understand how machines might be able to have consciousness. So certainly, I think more processing power to have consciousness of the kind that that we all have, I think that will be a necessary component. Will it be a sufficient component? No, I think there's more to the story.
But we don't know what that extra thing is, though.
No, but I think if you look at human beings, I mean, I'm 54 years old, so I've been on this earth for 54 years. And throughout that entire time, I've been in a society of other human beings in the world, on planet Earth, mostly at ground level on planet Earth. And throughout that entire experience, every moment, every waking moment of that, I've been learning. My neural networks have been learning. Very intensive learning in the early stages, slightly less learning in the later stages. But before I was born, there were billions of years where nature was doing a version of reinforcement learning with my ancestors, right? And through a very, very long, slow evolutionary process led up to me being delivered on this earth. And what was delivered? What was delivered was an organism that had some hardwired capabilities to be able to exist in our world. And exactly the limit of those hardwired capabilities is, I understand, it's not my specialist area, but I understand is the subject of debate. But there are some hardwired capabilities. But what we seem to be equipped with is the ability to learn both about our physical world, that is, what that evolutionary process delivered is an organism which was efficiently tuned to be able to learn about how to operate both in the physical world of planet Earth, where we find ourselves now, which is a very particular environmental niche, right? And actually you don't have to go far out of that environmental niche to find that human beings can't function there at all, but also an organism that was tuned to be able to learn how to exist in human societies. And I think the second aspect of that, the fact that we are basically social animals, and an awful lot of the learning that we've done about our world is not just about, if I drop something, it will fall to the ground, and that if something is brittle and it falls to the ground, it will smash, all of that kind of stuff, which we certainly learn, but actually learning how to interact with these other social animals, other human beings. I think that's just as important as, you know, learning about the physical world. At the moment, you know, we don't know how to give that kind of, for either of those two things, really, you know, the understanding of the physical world that we all acquire. We don't know how to do that. Human beings do it very efficiently. And my hypothesis is that Mother Nature has fine-tuned us to be able to learn about the physical world, but also about other social animals.
Coming on to social animals, this is an important element, which I think, to me, seems to be there's a big difference here between human beings and computers. And I just wondered what you think of it. When you think of social interactions, they're not purely rational interactions. They're not based upon reason or logic. They're based mostly upon emotions, whether it's love or fear or hate or whatever it may be. Those kind of emotions are part of social interaction, and they're fundamentally a part of human nature. But as far as I understand it, we don't have any mechanism for either putting emotions into machines or even any principal understanding of what it means to even think about trying to do that. Or am I wrong? Have we got anywhere near emotions and machines?
No, there's a lot of work on computational models of emotion, and usually the standard argument is, you know, if a machine is going to tell you that you can't have a bank loan, then it ought to be able to understand frustration and anger and so on, because that's what it's going to witness. But most of the work on that is, I think, rather early stage. But I think I would take a different stance. I mean, so what does it mean to exist in the social world? If you go back a few million years to our ancestors on the plains of Africa, and the social skills there were, you go back to those early primates, and they had to learn the primate equivalent of Michael Wooldridge 2 million years ago on the plains of Africa was in a social group of, let's say, 100 other apes. And to be able to exist in that society, this ape had to understand how that ape related to that ape. You know, that this ape was mating with that ape, that this ape was the alpha, whatever the terminology is, you get the idea, and so on. And there is a theory that humans have big brains, and we developed big brains, literally, that we developed big brains in order to be able to cope with large social groups. And what coping with large social groups means is understanding all of those different social relationships. And that required information processing capability, which evolution delivered via large cranial capacity, big brains, in other words. Now, what I find intriguing about that is that that's really saying that actually an awful lot of the skills, the ability to reason about, what Phil believes about Anne's beliefs and so on, that kind of thing, is quite closely connected with features of consciousness. I mean, so the animals that we recognize, there's a strong correlation between the ability to do that, to reason about what's called intentional reasoning about what another entity believes or desires and so on about another entity's beliefs and desires. And you can carry on doing that, what Phil believes about Anne's beliefs, about Bob's beliefs, that kind of thing. That seems quite closely correlated with animals that we would attribute consciousness to. So some primates can appear to be able to put them to reason about the beliefs and desires of other primates, but in a fairly simple way. But if you head down to dogs and then down to rats, maybe dogs could have some crude capability. There's some crude capability. Go down to rats, I'm a bit skeptical. Earthworms, I'd be very skeptical. In fact, no, I wouldn't accept that earthworms had that capability. In the same way, if you talk about consciousness, do earthworms have consciousness? Only in the crudest sense possible, I think. Go up to rats, I think I would concede that there is a certain type of rat consciousness. To dogs, a much richer type of consciousness, and so on. And so the ability to do that kind of social reasoning is quite closely correlated. And I think that's one of the interesting avenues to explore for research that's trying to understand machine consciousness.
Isn't it also connected, though, just to pursue this line a little bit further, connected to emotions as well, all of those things? You can imagine all of those creatures feeling emotions, except maybe the earthworm not. Well, I'll put it another way, let's put it more crudely than that, these organisms can experience pain, which is a mysterious thing in and of itself. But would you ever envisage at any time in the future at all that a machine could ever experience something like pain, or could be hardwired into it, so that they have a sense of what emotional suffering might be like? Is that possible?
Yeah, we're in the realm of speculation. I mean, I don't know. I see no logical reason why not. Is the answer. I'm not sure why we would want to build machines that could experience pain. I mean, the discussion that we're having now, of course, is completely divorced from those, and it's a fun discussion and I enjoy having it, but it is completely divorced on questions of whether we can or should.
I mean, in this sense that, for example, whenever you have a sanction against somebody, we have it against human beings. If they do something wrong, then they're punished in some way. You lock them up in prison or you fine them. All of these things are painful in some sense or other. It's something you want to avoid. You don't want to go anywhere near being locked up. You don't want to have a fine. You don't want to do various things. But there's no equivalent kind of experience that or accountability for a machine. And therefore, there's maybe there's no accountability or responsibility in a job that you might do. For example, you might say, "Well, I'm not going to do that because I'll suffer if I do that. That's not going to be very helpful." But there's no way a machine can be brought to experience that kind of avoidance. I'm not going to make a wrong decision because if I do, my manager's going to get on at me, and I'm not going to like that. That's just outside the whole scope of it, isn't it?
Yes, and I think what it comes down to is the issue about whether machines can or should be moral agents. That is, entities that can understand the consequences of their actions, and in particular, whether they're doing things which are right or wrong. And I think the conventional position in the AI community, which I would buy into, is that we shouldn't think about machines in those terms. Machines are not moral agents. The rightness or wrongness of what a machine does is down to the person that deploys that machine, not down to the machine itself. You can't hold machines accountable for their decisions. You build this machine to do things, you deploy it. The responsibility lies with you, not with the machine. And I think this is quite important, because I think it's quite important to that people can't abdicate their responsibilities, their moral responsibilities, to machines. That's not something that we should be thinking about at all. So I would tend to agree that that's not a path that we're likely to be going down.
Okay, we're coming to the end. I've got one last question for you, if I may, Michael, and that is, could you sketch out for us your view of what the future might look like? I know it's a bit of a wide open question, this, but looking ahead, say 10, 20, 30, 50 years, what kind of changes might society expect to find?
Well, so I think the future that we're heading in, firstly, AI is just one piece of the changes that are going on in society, and there are lots of other pieces. I mean, so consumption of fossil fuels and declining fossil fuel resources is going to change society in a really big way. More generally, I think computing itself has not done with us yet. I mean, we're talking about AI, but actually, there are many other computing technologies. Like, I mean, I'm wearing an Apple Watch. Wearable computing technologies. We're at the very, very, very beginning of that journey. So where we're going to is computer processing power basically embedded throughout the fabric of our world. Basically, in every device that we interact with, there will be computer processing capability. Those devices will be connected to the internet. They'll be able to talk to other devices. They'll be able to talk to the smartphone in your pocket, which will just get more and more powerful with more and more sensors, and it will take information from your Apple Watch and your Fitbit and whatever other devices that you're wearing. You can imagine your shoes being embedded with sensors which know when they're worn out, and then your smartphone says, oh, your shoes are pretty much worn out, you need to get new soles on them, or something like that. Or your bicycle tells your smartphone that the tire pressure is going down, that kind of thing. Every artifact in our physical world becoming equipped with computer processing capability. And then you add AI on top of that, and what it means is that AI gets everywhere that you have to make a decision, and AI can empower you, can help you every time you have to make a decision. The way to think about that is like sat-nav devices. Before sat-nav devices, you had maps and you had families that argued with each other. It's left here. No, it's not left here. Blah blah blah. As you tried to navigate using a conventional map. But what a sat-nav does is it takes the strain of a tedious and occasionally difficult cognitive process. It greatly simplifies that process for you. AI is going to do that everywhere. Every time you have to make a decision, AI will be there to help simplify that. And so the term that's sometimes used is what's called cognitive prostheses. It's just helping you in the same way that a calculator helps you when you want to do complex sums. The calculator takes the strain of that. In principle, I could do those myself, but a calculator is going to do it much faster and more accurately. So AI embedded throughout our environment is going to take the strain of a lot of complex cognitive tasks.
Although Elon Musk is fearful of AI, he is actually working on, I understand, neural interfaces. Is that something which will figure in our future?
I'm a skeptic about. I mean, I've seen Elon talk. I had the pleasure of being in China in a talk that he was giving, and he said it was going to be like downloading apps to your phone. And I'm very, very skeptical about that. I think Neuralink, what if it delivers anything? What it probably will deliver is things like the ability to control a computer, through a brain interface, which is not a new idea, and people have been working on that for quite a long time. But if they succeed, then I could imagine that becoming a thing. I'm not sure that you'd want to control a car using your brain, because if you just get distracted for a few seconds, that might go horribly wrong. But the idea that you download new skills to your brain like you download apps to your phone, I'm afraid I'm a bit skeptical about.
So a future to welcome rather than a future to fear.
Right, that if people want things to fear, I can give them a long list of things to fear, but you shouldn't be losing sleep about AI right now. But you should, I think, educate yourself about what the technology can and can't do. And there are some genuine issues that raise concern, but many of those issues are just continuations of trends in society, trends towards automation and the use of computers that have been with us for decades and in some cases centuries.
Professor Michael Wooldridge, thank you very much for your time and for a very interesting talk today.
Thanks for giving me the opportunity.
And if you want to look at that book, that's The Road to Conscious Machines, The Story of AI, Michael Wooldridge, and it's a Pelican book. I've got the hardback here, which I think was £20, but it may be coming out in paperback, I don't know.
It's out in paperback now.
Out in paperback too. Okay, thank you very much indeed.
Thank you.